before we get into actually solving some one-step equations, we first need to go over the prerequisite knowledge, or the things you need to know. And the first thing you need to know is what is a variable, because I'm going to be using that word here and there. A variable, according to the definition here, is a symbol that represents an unknown or changing numerical value. To make that a little easier for you, I'm going to say it's the letter. Now, the letter is what we are trying to figure out, and before you give me the question, why are there letters in math now, remember, we can replace this letter with anything we want. A question mark, if that makes more sense to you, a smiley face if you wanted to. Long story short, we just want to figure out what this missing value is. So when I say variable, I'm talking about the letter. The second thing you're going to need to know is an inverse operation. Now, inverse operation just means opposite operation. You first want to remember that an operation would be something like adding, subtracting, multiplying, and dividing. And inverse just means opposite. Adding and subtracting are opposites, and multiplying and dividing are opposites. So those are the three things you're going to want to know. What is an operation? What is an inverse operation? And what is a variable? Now that we have those three things in mind, let's go ahead and start with our first example with only positive numbers. Now, a lot of you are probably able to do this right in your head, as you could probably say, oh, 7 plus 5 equals 12. Therefore, why do I even have to show any of my work? Well, one, your teacher's going to want you to show your work. And two, you want to show your work as you want to make sure you can follow along once you get into 2-step, 3-step, 4-step problems. There will be a lot more steps in math later on. So what you want to do is use this as an opportunity to start practicing the necessary skills you'll need. Now, first thing you're going to want to do is draw a line directly down through your equal sign, then across the bottom like this. Just give yourself just enough space underneath to write some numbers. Now, our goal here is going to be to isolate the variable, or in other words, get the letter by itself. In order to do that, we need to do the opposite operation, or the inverse operation, to whatever else is on the same side of the equal sign as our x. Now, we can see that we have a plus 5. And the opposite of plus, or the opposite of addition, is subtraction. So what we're going to do is write a minus 5 underneath that plus 5. Now you need to remember, an equal sign means everything on the left has to be equal to the right. And if we're going to put a minus 5 on the left, we have to put a minus 5 on the right. Now let's go ahead and do the math. This right here, this plus 5 and this minus 5, what is 5 minus 5? Well, positive 5 minus 5 is going to be 0, so we can go ahead and just cancel those out. We know that's going to disappear, turn into 0. This over here is going to be 12 minus 5, which we will see is 7. Now, what do we do with the x? Well, we didn't do anything to it. It's still part of the problem, so what you're going to do is simply bring it down and write it down here. So now we know x equals 7. Our next problem is going to have subtraction as part of the equation. This equation reads x minus 4 equals 11. Now, once again, we're going to try to isolate the variable, which means get the x all by itself. And in order to do that, we need to get rid of whatever else is on the same side of the equal sign as our x. In this case, it is the minus 4. So we're going to write the opposite of minus 4 down here, which is plus 4. Now, minus 4 and plus 4 are opposites, so they just cancel each other out. And then we're going to go ahead and do 11 plus 4 on the right side. And 11 plus 4 is 15. And once again, we didn't do anything to the x right here, so we're going to drop it down and just write our x again. And now we can see that x equals 15. Now this is where things are going to get a little bit tricky. We're going to start introducing negative numbers to the problem, such as our first example with negative numbers here, x plus negative 3 equals 1. Now before you get too worried, there is something easy to remember when it comes to adding and subtracting negative numbers. For example, if we were to add negative 3, that is actually the same thing as x minus 3. Same deal when we look at our next example, which we're going to go over in a second, which is x minus negative 4 equals 2. Minus a negative is the same thing as addition. So what I'll do is I'll give you this cheat sheet here, and it may help to write this down in your notebook or any sort of scratch paper you might be working on right now. Adding a negative is the same thing as subtracting a positive. And subtracting a negative is the same thing as adding a positive. As long as you remember this, we will be able to rewrite our problems to look much more simple. So if you're worried about negative numbers, don't worry, this small trick should make your life a lot easier. If we go back to our example 3 now, it should be a lot more doable and look a lot less intimidating. X plus negative 3 equals 1, we now know can be rewritten as x minus 3 equals 1. Now that we can see this is just a subtraction problem, we can do the inverse operation of subtraction, which is addition, and we can just add 3 to both sides of the equation. We already know that minus 3 and plus 3 are opposites, so they will cancel out. And the only real calculation we have to do is 1 plus 3, which is just going to be 4. Once again, we just bring down our x, and we can see that x equals 4. Let's go ahead and look at a similar example, but this time with subtracting a negative. This example reads x minus negative 2 equals 7. Now, just like on the last problem, we want to rewrite it so it's easier to look at. So instead of x minus negative 2, let's say x plus 2 instead. And since we already know about inverse or opposite operations, we're going to go ahead and subtract 2 from both sides. Our 2's are going to cancel out because they're opposites, and we just have 7 minus 2, which is 5. Bring down your x, and once again, we can figure out what our variable equals, and our solution is x equals 5. I'm going to go over one last kind of problem very quickly, and that's because we've technically done this before. Our last example is going to be 5 plus x equals 12. And as you can see, we now have 5 before our variable, or before our letter. This is actually the exact same kind of problem as the very first problem that we've already done. If you remember, our first problem was x plus 5 equals 12. Just because the terms got mixed around does not mean you do this any differently. If you have a positive 5 here, you are still going to do the inverse of whatever positive 5 is. And the opposite of this would be a negative 5. Now you can look at this as a negative 5 or a minus 5, however you want to look at it. But either way, we're going to subtract 5 from both sides of the equation. These 5's are going to cancel out, and we still end up with x equals 7, just like before. Sometimes your variable will be first, other times your variable will be second, but the same rules still apply. Grab a piece of scratch paper because now I'm going to put up 4 practice problems for you to try on your own. Give yourself some time on these, go ahead and click pause on the video and see if you can work them out by hand. After you unpause the video, and there will be a countdown in a second, I will give you the answer to each of these problems. Here's your countdown, make sure you pause it before it's up. Here are the answers to all the problems, and check how you did. Chances are you did a little better than you thought you would, and even if you got them wrong, that is completely okay. A big thing about math is even if you get the problems wrong, as long as you know what you did wrong, that means you learned how to do it and you're not going to make the same mistake again. I hope this video helped you out a bit. Thanks for the like if it did, and if I make any other videos, I hope my next video can help you as well. Thanks for watching.